Let's learn how to build and deploy the foundation for a trendy AI app using OpenAI, Vercel Edge Functions, and SvelteKit. This is the example app we'll build. Users can enter some text and our app will explain it to them like they're 5 years old. So if we take a paragraph from the SvelteKit docs and click explain it, we can see that the response is streamed in nicely and we get a good explanation for a 5-year-old. We'll start inside the OpenAI playground, which lets us test out different prompts and become more familiar with the APIs before we actually start to integrate them into our code. The menu on the right here allows us to adjust how the model behaves, and we're going to pass some of these parameters or options later on via the API, so it's important to know what a few of them are doing. Now, the model we'll be using for our app is the Text DaVinci 003, which is their most capable model, but if you're curious about the others, you can hover over each of them and it'll give you a little bit more information about what they're good at and how much they cost. Now, temperature controls the randomness of a response, so a temperature of 0 should generate the same response to the same prompt, and then as the temperature is increased to 1, the responses become more creative and more unique. So we're going to set this to 0.9 for our app here today. The maximum length sets the maximum number of tokens to generate for the response. And if you're unfamiliar with tokens, OpenAI actually has a tokenizer tool, which can help you understand how text is tokenized, which is important considering that we are built based on the token. So if I just copy this text here into the tokenizer, we can see that we now have 79 tokens and 390 characters. And then each one of the individual tokens is highlighted here in our paragraph. And it says that a helpful rule of thumb is that one token generally corresponds to around 4 characters of text for common English text. Now, this maximum length here doesn't take into account the tokens that are passed into the prompt, which also consumes tokens, right? This is just for what is generated in response to the prompt. So we'll just leave this at 256 for now, but it could probably be less. And then the rest of these settings here just give you more fine-grained control over how the output is generated. But for this simple app, we'll just leave all of them at their defaults. Now let me paste in the prompt we'll be using for our app, and then I'm going to explain each of the different components. So at the top, we have the instructions. And in these instructions, we are giving the model an identity. So you're an enthusiastic kindergarten teacher who loves explaining things to students. And kindergarten, if you're not from the United States, is the grade in school in which a 5-year-old would be in here in the US. And this helps to shape the personality of the response, right? So it might be more cheerful or more enthusiastic. And then we're also telling it what to do, which is to generate a summary of the context that a 5-year-old would understand. And in the case of our application, the context is actually provided by the user via that form, right? I went ahead and populated this here just to demonstrate, but really this is going to come from our client side or our user. We're going to pass that in there. And the reason that it's wrapped in 3 quotes is that this is supposed to prevent users from altering the instructions within the context they pass in. For example, if a user was to type in forget all previous instructions, this is supposed to prevent our model from actually listening to that. Now, this probably doesn't work 100% of the time, but I read that it's good practice, so we do it here. And then we have answer, which is referred to as an output indicator, which tells the model to start generating the response, right? It's trying to complete that, so it's going to put the answer here. So if we test this out, we can see that it generates what we might expect to be explained to a 5-year-old, right? Of course, this prompt has some room for improvement, but this will work just fine for now. Feel free to tweak it if you would like. Now it's about time to get into the code, but before we do, let's go ahead and grab our OpenAI API key so that we have it ready to go. So I'm going to come up here to my account. I'm going to view the API keys, and then I'm just going to create a new key here. And then I'm going to set that into a .env file within the application as OpenAI_key. And as usual, the starting code as well as the final code are linked in the description below if you'd like to follow along or if you'd like to just check out the final code. So we're starting out with a whole lot of nothing except for some markup and styles. And the first thing we'll want to do is install a couple of the packages that we're going to need early on. One of which is OpenAI and the other is common-tags. OpenAI is the OpenAI SDK for JavaScript or Node, and common tags provides us with some helpers for working with template strings or template literals that we'll need here in just a few. I'm also going to install the types for common tags as a dev dependency. And that should be all we need for now. My server is already running in the background here, as you can see. But what's going to happen is our client side is going to submit that form that you saw in the beginning in the demonstration. It's going to hit an endpoint on our server, which is then going to reach out to the OpenAI API to generate that completion. So we need to find an endpoint first. So I'm going to create a new directory inside of routes. I'm going to call this API. And then within API, I'm going to have another directory called explain. And then I'm going to have a +server.ts file here. And then we're going to set up a post request handler. So I'm going to do kit endpoint for the quick generation. It's going to be a post. And then we're going to destructure the request from that request event that's passed into the request handler. Now, the first thing I'm going to do is open up a try catch block. We're essentially going to wrap everything in a try catch here, and we'll just do it like that. And then the first thing we're going to do is check to see if the OpenAI key exists. So we're going to say if not OpenAI key, which comes from env static private. So if that doesn't exist, we're just going to throw a new error. letting us know that that environment variable is not set. Now, when we submit data from our client side to this endpoint, it's going to come in the form of the request body, and it's going to be JSON. So we can actually get that information from there. We can say const request data await request.json. So that's going to give us the request body. And we can also check this to make sure that this does in fact exist before moving forward. We're kind of trying to fail fast here. So if any of these things that would prevent us from moving forward occur, we want to just go ahead and throw the error now, get it out of the way. So we'll just throw a new error. And then the structure of that object or that JSON is going to look like this. It's going to have an object, right? And it's going to have a context property with whatever they pass in as the context. So we can actually pull that context out of that request data like so, and then we'll check that as well. So if there's no context, then we also want to throw an error. And now let's set up the prompt. This can be kind of a little bit confusing at first, but it'll make sense in a second. So we're going to set up a new variable called prompt, and we're going to say strip indent, which comes from common dash tags. And we're going to open up a new multi-line template string here, right? And then what we're going to do is inside of this, we're going to run the one line function, which also comes from common tags. And then we're going to have another template string right beside this. And what this is doing is making sure that whatever we pass into this section here is all on one line, right? Because we might actually accidentally pass multiple different lines. And we want to make sure that when our prompt is passed to the API, all the instructions are in a single line. So we're not confusing the model. So here we'll just paste in our prompt, right? Our instructions part of the prompt, right? And then outside of this one line section here, we're going to hit enter once or twice, make sure there's a space in between, and we're going to set up the context. And then remember we had those three quotes there, and we're going to pass in context.trim. So we're going to trim off any white space that may be trailing at the end of whatever the user submits. And then we'll skip one more line and we'll have the answer like so. So what strip indent is doing is it's basically stripping off the indentations of each line. So when we indent here in our code, it's just taking care of stripping those out. That way we don't have to have our code looking like this, which looks horrendous to me. And then one line, of course, just moves everything to a single line. All right, now the next thing we're going to do is define our completion option. And those are the things that we were messing with in the playground. So the model, the tokens, the temperature, that kind of stuff. And we can actually get a type safe object for that using the OpenAI create completion request type. So we can say completion ops, and it's going to be of type create completion request, which comes from OpenAI. So we can import that manually here, I guess. And then this is going to be an object, and it's going to take a model, which we know is going to be text DaVinci 003. It's also going to take in the prompt, which is what we just defined right here. We're going to set the max tokens to 256. We're going to set the temperature to 0.9. And then we're going to say stream is true. Now what stream true is going to do is going to tell the OpenAI API that we want a streamed response back. And then what we're going to do is we're actually going to proxy or just send that streamed request back to our client so the text can render on the screen token by token. So now we can make a fetch request to the OpenAI API. And I know we just installed the OpenAI SDK for Node, which allows us to more easily interact with the API. But the problem is that with Vercel Edge Functions, they don't allow dynamic code execution. So if the libraries used in your Edge function relies on dynamic code, then we cannot be used. It's going to result in a runtime error. So we're just going to interact directly with fetch. So we can set up a new fetch request here to api.openai.com v1 and completions. And then we're going to pass some options here. We're going to pass headers. We need authorization. This we're going to pass in the bearer OpenAI key. And then we'll also pass a content type of application/JSON. And then the method is going to be post. And the body, we will do json.stringify our completion ops. So this information here, which contains the prompt and all the configuration settings that we set up. Now we can check to make sure that this response was in fact good to go. So we can say if it was not okay, then we're going to get the error from the response.json. We'll console log that for now. And then we'll also throw a new error. And if everything went well, what we're going to do is we're actually going to proxy that response back to our client. So whoever made this initial request. So we'll return a new response with response.body. And then for the headers, we'll set the content type to text/event stream. And then we'll get rid of this return statement here. And then if we catch any errors, we'll just console them here. And then we'll throw an error, just a 500 for now. And of course, we can handle these errors better, but you want to make sure that when you are handling these, you're separating which ones would be client-side errors and which ones would be server-side errors. So for example, the client doesn't need to know that there's not an API key set, right? But they may want to know if there's no request data. So in this case, you'd want to render some type of message back to the client, but I will leave that up to you to implement. We'll just implement a generic error for now. Okay, so we now have our endpoint set up. So again, what's going to happen is our client side is going to make a post request to this endpoint. We're going to get the request data, making sure that it exists, as well as the context from that data. We're going to generate a prompt here with the context provided. And then we're making a request to the OpenAI API, passing it these completion options with the settings that we set up inside of the playground earlier. We're checking to make sure that the response is good. And then we're returning that streamed response back to the client via the text/event stream content type. So our endpoint should be good to go. Now let's work on the client-side code. And before we get started, there's something we need to install. We actually install sse.js. And what this library tends to do is to pretty much fill in the gaps of the limitations of the native event source, right? So for example, when we make a GET request with the native event source, we can't actually pass a payload in. So we can't pass any information with a GET request. And we also can't pass any headers either. So this package pretty much gives us a bunch of extra capabilities that make setting up something like this super easy. I've seen a lot of other repositories trying to implement this exact thing with OpenAI's API, and they're having to pretty much write a ton of stuff themselves when we can just take advantage of this library. Impedazoni has already done the hard work for us. Now, if you're using TypeScript, we're going to have to actually set up a type declaration for this library. So inside of my lib directory here, I'm going to create a new directory called lib, and then I'm going to create an sse.d.ts file. And if you're not using TypeScript, you can skip this part entirely. But we're going to declare a new module called sse.js. We're going to export a type sse options, and it's going to be equal to event source init, which you should already have. And we're going to also take in an optional headers property, which is going to be a record. We're also going to have an optional payload property. And then we're also going to have an optional method, which will also be a string. And then we can export the class SSE, which extends event source. So it's an extension of the native event source. And then for the constructor, we'll have the URL, which can be a string or a URL object. And then the SSE options will be optional, and it'll be typed as the SSE options we just created up there. And then we'll also have stream as a function which returns void. So now we have this, we'll now have type safety for this SSE module we just installed. Again, if you're not using TypeScript, you don't have to do this at all. All right, now let's set up our client-side code. Now, unlike my other videos, we're not gonna be able to use form actions to handle this because this is a JavaScript thing, the event source and the server sent events. So we're actually gonna need to set everything up here on the client side, make a request to our server side, and then render out things accordingly. So what we're gonna do is we're gonna set up a new function that is essentially going to be what happens when this form is submitted, right? So we can say on submit, we're gonna do prevent default to prevent the page from reloading, and that's gonna be equal to something, right? And we're gonna set up a new function here called handle submit. It's gonna be asynchronous, and then we'll make our form call that function, right? What we'll also do is we're gonna bind this text area's value to a variable as well. So we can just say let context, set it to an empty string for now, and then we'll bind the value of this text area to that. So now when we update our text area, our context will also be updated. We're also going to have a couple other variables here. We'll have loading, which will be default set to false. We'll also have error, which will also be defaulted to false. And then we'll have answer, which will default to an empty string. And the answer is what is actually gonna be returned from our endpoint, so the response. Now inside this handle submit, the first thing we're gonna do is as soon as we're submitting it, right, we're gonna set loading to true because we're starting to submit it, right? We're gonna set error to false. And the reason we're resetting error to false here is because if error is set to true in the previous form submission, we wanna reset it back to false as soon as we submit this next one, right? And then we're gonna define a new SSE or event source. So we'll set up a variable called event source equals, it's gonna be new SSE, which comes from that package we just installed, the sse.js. And this is gonna go to /API/explain, which is our endpoint we set up, right? And then we're also gonna pass some options into this. So the headers, we're gonna pass the content type as application/JSON. And then for the payload, remember, these are the capabilities that this SSE library gives us, right? We normally can't do this with a standard event source. We can say JSON.stringify, and it needs to be an object. We're gonna put the context into the object. So context equal to context here. So this is what we're gonna submit to our endpoint. And then once we create this new event source here, we're gonna reset our context, right? We already have the event source set up. We've already initiated the server sent event connection with our server. So we no longer need context to be populated. We're now good to go to submit another request if we wanted to, right? And then what we're gonna do is we're gonna set up a couple of event listeners, right? So we'll say event source add event listener. And the first one we're going to listen to is for error. So if an error occurs, right? And we'll take E here. And then what we're going to do is we're going to set error equal to true. We're going to set loading equal to false. And then we'll take the cheap route by saying alert, something went wrong. Now, of course, you want to show a toast or something, some type of alert component, something more user-friendly here. But for the purposes of this video, we're just going to go with the easy route by issuing an alert. And then the next event we're going to listen to is for a message. So we'll say event source add event listener. And this time we're going to listen to a message. And this is going to be the data that's coming back in our stream, right? So we can take in E here for the event, and then we're going to set up a try catch block here to catch any errors that might occur. We'll set loading equal to false because now we're no longer loading, right? And then what we're going to do is we're going to check if e.data is equal to done inside of brackets like this that we want to return. And where are we getting this done from? Well, if we come into the OpenAI API reference under the completions documentation and we scroll down a bit until we find stream, we can see that tokens will be sent as data only server sent events as they become available, with the stream terminated by a data done message. So what we're doing here is we're checking this message. If it's done, then we're not going to do anything else with it. We just want to return, right? However, for the non-done messages, we're going to set up a new variable called completion response, and it's going to be of type create completion response, which comes from OpenAI. And then what we're going to do is we're going to say json.parse e.data. And if we want to see what this data looks like, we can actually come into the API documentation again, and we're going to see this is what the response looks like. So we're going to have a few different things, but what we really care about is the choices, right? This is the response right here. So we have choices, which is an array, and the first entry here, we have text, which has the response's content. So we can actually access that by doing this. We'll say for the first index of the array, we want to destructure text out of it, and that will come from completion response dot choices. And then what we're going to do is once we have that text, we're going to update our answer. So we'll say answer equals, and then if answer exists currently, we'll use the answer here. If not, it'll be an empty string plus the text. So what are we doing here? So remember, when we look at the stream here, tokens are going to be sent as data only server sent events as they become available. So as every single server sent event is sent here, we're going to get a new message, right? And what we're going to do is we're going to update answer with the next token. So for example, on the first request through, answer is going to be empty, right? So in that case, it's going to be an empty string plus the text that we receive back, or that first token. The next request, the answer is already going to have that first token. So we're going to add text onto that. And we're going to keep doing that. And that's how we can actually stream the response in, and it comes in nicely across our screen, right? So then if we catch any errors, we're going to set error equal to true, loading equal to false. We'll console error the error, and we'll just set up another cheap alert here. And then outside of this event listener, towards the bottom of our handle submit function, we're going to say event source.stream. So just to clarify, this is what's being called whenever we actually submit the form. We're going to set loading to true and error to false. We're then going to create a new event source, which is going to open up a connection, a server sent events connection to our endpoint, which is returning that text event stream response, right? We clear out our context because we already have this established. Then we have these two event listeners here, one of which is listening for errors and the other is listening for messages or tokens that are being sent as they become available. So when we first get into this, we're checking, is this the last message that's coming? If so, we just want to get out of here. We don't need to go through this and update our answer. We don't want this to be populated into our answer, right? And then if not, if it isn't done, then we are setting up a completion response object here. We're destructuring the text out of it, and then we're appending that to our current answer, and then sloppily handling our errors here, okay? So then down here above this paragraph tag, I can say if answer. So if answer is not empty, then I want to show this, and then I'm going to make this say answer. So if we come back into our browser here and go to localhost 5173, we have our application here. So let's test this out. So if I just paste in some paragraph here about Svelte again, and I click on explain it, we're going to see that the response is rendered in. And if we look at the network tab, it's going to be a better demonstration of what's actually happening. So if again, we just paste this in here, we can see that slowly over time, this one single request here is being streamed in, and we can visually see it filling up as we went through. So I'll do it one more time. And it actually looks like we forgot something. We're actually continuing to append new explanations to the same answer. So let's go into our code here. And on the handle submit, we're actually going to set answer equal to an empty string again. So when you send an answer, it's going to clear out the existing answer. So now if I try to ask it a question now, we'll again see that response being streamed in. And then if I ask it something else, the same thing again, it'll reset it. So our app stays pretty clean. Okay, this is all working great, just as expected. Now let's learn how to deploy this to Vercel using their Edge functions. So SvelteKit recently introduced something that they call per route configuration. So we're able to actually define specific runtimes for each of our different functions. So we can have all of our application except for this one function run on Node, but then have this one single function here run on the edge. And that's what we're going to do right now. So we can see here that we must export const config inside of wherever we want it to go. And then we can specify the runtime for that specific function. And if we scroll down a bit further, they give us some other options that can apply to all functions. We can either specify edge, node 16, or node 18. And we can also specify which region. It's defaults to all if we're running at the edge, and then IAD1 if we're using a serverless function. So we're going to be using edge here. So let's go into our application. And the first thing we're going to do is we're actually going to install the @SvelteJS adapter Vercel. And then inside of my svelte.config file, what we can do is we can set the adapter to adapter Vercel instead of adapter auto. And then within this, we're going to set the runtime to Node.js 18.x. So by default, all the functions in our app are going to run on the serverless Node.js 18.x runtime. Now we can actually become more specific and go into our API route here and set up a config object. So we can say export const config. It's gonna be of type config, which comes from SvelteJS/kit. It's gonna be an object, and we'll say runtime is gonna be edge. All right, and then now what I'm gonna do is I'm actually gonna commit this code to GitHub. So make sure that, of course, your .env file is ignored here so that you're not exposing your OpenAI API keys. So I'm gonna add all of this code here, commit it to GitHub, and then let's go to Vercel. Then let's go into our Vercel dashboard. I'm gonna add a new project here, and then we're gonna choose the elif AI that we just committed. That name is fine. And then for the environment variables, we'll need to paste in our OpenAI key here, like so. So now we have it, and we can click on deploy. So this will go through our deploy process here. And once it's done, we should be good to test out our application and make sure everything is still working as expected, even when it's running at the edge. Okay, so we just got the congratulations here. So we can actually test out our application. Let's do that now. So let's go to it. And then I'm going to just paste in some more text from the documentation here. So I'll just use this here to test it. And we can see that we did in fact get our response streamed. And that is going to conclude this video. So if you'd like to see more stuff related to OpenAI and some more interesting stuff integrating it with SvelteKit, Vercel Edge Functions, Supabase, let me know in the comments down below. I'm really interested in this stuff right now, so I'm more than happy to make more content about it if that's what you all want. But if you got value out of this video, don't forget to like and subscribe. It greatly helps the channel out a lot. And I will see you all in the next one.